So today you took the practice quiz, and we're going to take a little bit of time to go over the practice quiz and maybe answer any questions that you may or may not have. For the first learning target, we had classifying different types of matter as element, compound, or mixture. In the case of the first one, copper oxide, I classified as a compound. It is a compound because it's made up of two or more elements, the copper and the oxygen. In the case of salt water, I said it was a mixture. The definition of a mixture is a substance made up of two or more different pure substances. And in this case, we have salt, which is one of the pure substances, and water, which is the other. Lastly, nitrogen is an element because it's only made up of one type of atom. In this case, just nitrogen atoms. Any questions about this section? Yes?
What's a pure substance?
Question is, what's a pure substance? Pure substance is basically an element or a compound because the element is just pure atoms of that particular element.
So aren't a mixture and a compound the same thing?
Because, so hold on. And then a compound is two or more elements that are bonded together, but it's just those two elements. So for example, if I had a pile of aluminum atoms or a pile of aluminum foil, it would just be aluminum atoms. Okay, but if I have a pile of salt, table salt, pure kosher table salt, kosher, yep, nothing added to it, it would just be sodium and chlorine atoms that are bonded together. Now a mixture, okay, is two or more pure substances, different pure substances mixed together. So for example, if I took salt, right, and aluminum, I don't know why you do that, but you mix it together, you now have a mixture.
Okay.
Did you see the subtle difference? Okay. Next one, you had to identify chemical and or physical change. Statue of Liberty turning from a copper color to a green color is a chemical change, obvious color change. You could have said something like it oxidized, and then that's clearly a chemical change as well, but we didn't give you that information. An icicle forms as water goes from liquid to a solid. This is a physical change. Melting and freezing are a change of state, which means you still have water. And then a piece of paper is folded into an origami crane. That's a physical change as well, because in that instance, the size of the paper has changed, but the paper did not. Questions about those? The next part, you were asked to diagram different states of matter. So to refresh your memory, solids are organized particles and touching particles. So that's what your solid is. Nitrogen, in this case, happens to be an element. I know it's an element because it's just nitrogen. So I'm going to use a square to represent nitrogen. And I'm going to draw 1, 2. Oh, that's not a square. I don't know what that is. 2, 3, 4, 5, 6. So that's organized and touching. So those are that's my solid nitrogen. Well, I was just drawing 6. If you drew 8, because that's what I was doing in the past, totally fine. You just need to have more than, like, say, 2 or 3 so that I know that there's organization. Okay. The next one is a liquid, and you might recall that liquids are not organized, but still touching. And this is a compound because it's made up of 2 or more atoms. And so I'm going to say that aluminum is going to be my triangle, and chlorine will probably be a circle. And then we have to remember that when we draw compounds, they are bonded together with a line. So in this instance, I'm going to draw them as organized and touching as I possibly can. So you might have something like this. And then you might have something like this. Hang on, I'm getting ahead of myself here. Yep, I should have drawn that a little bit longer. they're touching now. They're touching now. And then I might erase this. I might erase this and do something like this. I don't know. So disorganized, but still touching in some way, shape, or form. Man, the last one I drew last hour was way better than that. I apologize. So now, last one is a gas. Gases are not organized and not touching. So here again, we have a compound. So I'm going to say that we have something like, I don't know, sodium, which I might make a heart, and oxide, which I might make a star, something like that. So then what I'm going to do is I'm going to draw this as a gas. And we should remember that because it's a compound, they are bonded together with a line. So here I'm going to go and draw like, I don't know, 4 or 5 hearts. That's not a heart. That's best I got. And then we'll draw some stars. And then we'll draw some lines to indicate that they are bonded together, but not touching and not organized. So that's the best way that we could probably represent a gas. Questions about drawing model of matter diagrams for solid, liquid, and gas. Next one, you're supposed to be able to read experimental descriptions and then draw the appropriate MOM diagram. So here we have a chunk of calcium being thrown in a bucket of water, and it dissolves. So we're going to start with solid calcium. So this is going to be a solid, and I'm going to give myself a key here saying calcium is going to be a square. So I'm going to draw 6 squares of calcium, solid, touching, organized. Calcium dissolved in water, then, you may recall that when we represent water, we use an X. So I'm going to take those same 6 chunks of calcium and spread them out. And then I'm going to dissolve them with water, or not dissolve, I guess. Yeah, I guess, because we said they're dissolved. So I'm going to add them to the water. And note that what I've done here is I've done my very, very best to indicate that the water itself is surrounding the different pieces of calcium. Also note that I use the same number of calcium squares in both cases, in both boxes. Those are things I'm going to be looking for when I assess you tomorrow. Next one, we have copper, which is a solid. So we'll do it again. Solid, we'll make it a square. And when we do that, you're going to have I'm going to do 1, 2, 3, 4, 5, 6. And then we have aqueous silver nitrate solution, and that's something we haven't talked about yet on this practice quiz. So the first thing I would like to point out, this is an element. First thing I would like to point out is that this is a compound. And aqueous and solution tell me that it's going to be dissolved in water, so we're going to use an X. So for silver, I'm going to make it a triangle. Nitrate, I'm going to make it a purple circle. And I'm going to bond them together with a line. Now I'm going to draw this aqueous solution, something like this. And bond them together with a line. And then lastly, surround each of those particles with X's that we know to represent water. And then the last thing that you're going to do is the next box. And the next box here, we have silver solid, okay? So now we're going to take our silver, which was triangles, and we're going to make it into a solid. So we're going to draw 6 triangles, something like that, indicating we have a solid at the bottom. We have aqueous copper nitrate solution. We know that the copper is a square, so we're going to draw that. And then the nitrate we said was circular purple circles, so we'll do something like that. And then we will bond those together. And then we will, because it's aqueous and it's a solution, we will surround those with water. And I'm not going to require that you do this on the test tomorrow, that you draw it in color. But what I do want you to do is be aware of what you're drawing. So like if the X for water happens to look like your line that's bonding something together and it looks like you're sticking two different units together, I would mark it wrong. So make sure that you're very aware of what it is you're drawing. Any questions here? Okay. Then we talked about law of conservation of mass. So we have this person, Nora here, who placed a weigh boat on the scale and zeroed it out. They put some zinc in there and recorded a mass of 5 grams. They removed the weigh boat and put a beaker on there, zeroed again, measured out 10 grams of hydrochloric acid. So their total starting mass was 15 grams. This person then dumped the zinc into the beaker. They observed some bubbling occurring, and they waited for the bubbling to stop. And then they decided they remassed the beaker. So now they want to know is will the beaker be 15 grams, more than 15 grams, or less than 15 grams? In this case, the answer should be less than 15 grams. And we're looking for you to tell me in terms of your explanation something like formation of a gas or formation of bubbles. Means there's a gas present. That gas has mass and left the system. Now, you don't have to write all of the things that I wrote, but you should write something to the effect of the bubbles have mass and the bubbles left the system. So something in that vein is what I would be looking for. Now we have another person with a weigh boat, and they measure out 8 grams of Epsom salt. Then they put a beaker on there, and they put 20 grams of water in the beaker. So now they have a total mass of 28 grams. So then they dump the Epsom salt into the beaker, and they stir until the solution goes clear. And at that point, they remass the balance, and they're trying to decide if it would be more than, less than, or the same as 28 grams. And hopefully you came up with same as 28 grams. So in this case, the Epsom salt dissolved in the water, and no mass was added or lost by the system. Questions there? Again, I'd probably be looking for something in the vein of no mass was added or lost in the system. Now we're going to do some calculations. Woo! We spent 2 days on these in class. Well, 2.5, 3 days, something like that. So let's take a look. Now, first one, we're starting with 85.03 grams of silver. We're converting it to moles of silver. So I'm going to take my 85.03 grams of silver, put it over 1. And since I'm going from mass to moles, it's going to be a one-step problem. So I need to know the relationship between grams of silver and moles of silver. And you may recall that that relationship is whatever the average atomic mass on the periodic table is equal to 1 mole. And so the average atomic mass of silver on the periodic table is 107.87 grams. So I'm going to take that 107.87 grams and I'm going to put unit of grams of silver on the bottom, and I'm going to put moles of silver on the top. I'm going to fill in my relationship values. So 1 mole is equal to 107.87 grams. I'm going to grab my handy dandy calculator, and I'm going to take 85.03 divided by 107.87. And the calculator gives me an answer something like 0.7882636507. The next thing I'm going to do is assess my significant figures. So I'm going to draw an arrow here and see that I have 1, 2, 3, 4 sig figs. So I'm going to draw an arrow here through that 0 and 1, 2, 3, 4 sig figs. I'm going to see that that 6 can round the 2 up. So my final answer here is going to be something like 0.7883 moles of silver. The next one is a little bit more involved. So in this case, we're going to take our 3.82 times 10 to the 24 atoms of phosphorus, and we're going to convert it to grams of phosphorus. And you may recall from yesterday that there's no way to go directly from atoms to grams. We have to go atoms to moles to grams. So I'm going to take the 3.82 times 10 to the 24th atoms of phosphorus and put it over 1. And I'm going to go atoms to moles and then moles to mass. But when I do this, the first thing I need to do is identify the relationship between atoms and moles. So I'm looking for the relationship between atoms of phosphorus and moles of phosphorus. And I know that the relationship is 1 mole of phosphorus is equal to 6.02 times 10 to the 23rd atoms of phosphorus. So I'm going to put atoms of phosphorus on the bottom so that they cancel out. Put moles of phosphorus on the top so that's what is my intermediate step. I have 1 mole of phosphorus being equal to 6.02 times 10 to the 23rd atoms of phosphorus. And so my atoms of phosphorus are canceling out. I know I'm going to go from atoms of phosphorus to moles of phosphorus and moles of phosphorus to mass of phosphorus. So I'm looking for grams of phosphorus, the relationship between grams of phosphorus and moles of phosphorus. And I look at the periodic table again because we know that the average atomic mass of the element on the periodic table is equal to 1 mole. So I have 1 mole of phosphorus is equal to phosphorus's mass is 30.97 grams. So I'm going to set up this problem so that moles of phosphorus is on the bottom, so they cancel out. Grams of phosphorus is on the top, and I'm going to take 30.97 grams of phosphorus over 1 mole. And now I can go ahead and calculate this. So I'm going to take the 3.82 times 10 to the 24th divided by 6.02 times 10 to the 23rd times 30.97. And that calculator then gives me the answer of 196.520,598. I do need to assess my significant figure, so I draw an arrow coming in from the left. 1, 2, 3. So I have 3 sig figs for my given. So 1, 2, 3. Draw a line. That 5 can round the 6 up. So my final answer will be 197 grams of phosphorus. And then the last one we're going to be doing here is we're going to be converting moles of helium to atoms of helium. So I know that I've got 2.46 moles of helium all the way over to atoms of helium. So here's my 2.46 moles of helium over 1. And now I need to know the relationship between moles and atoms of helium. So I need to remember that atoms of helium is equal to moles of helium. I need to remember that 1 mole of helium is equal to 6.02 times 10 to the 23rd atoms of helium. So I'm going to set this problem up so moles of helium cancels out, and atoms of helium is on the top. And I'm going to fill in my values. And then I'm going to calculate. So 2.46 times 6.02 times 10 to the 23rd gives me a value in my calculator to be something like 1.48092 times 10 to the 24th. I'm going to assess significant figures, drawing an arrow and counting 1, 2, 3. 3 sig figs here. Draw an arrow and count 1, 2, 3. That 0 cannot round that 8 up. So I'm going to take the 1.48 times 10 to the 24th. Atoms of helium will be my final answer. Questions? Your homework tonight is to study, practice problems. Okay, so after we completed all of the problems of the quiz, I drew on the bottom of this practice the mole flow chart that we used in my class the other day. So remember, when you're going from mass to moles, you need to use the relationship of the average atomic mass of the element on the periodic table equal to 1 mole. And when you go from moles to atoms, you need to use the 6.02 times 10 to the 23rd is equal to 1 mole. The way that I've used it in the past is I would, wrong thing, is I would say, like, if I'm going to go from moles to atoms, so like if I covered moles and I covered atoms, I didn't need anything with the mass. If I was going to go from mass to atoms, I would put my finger over mass, put my finger over atoms, and see that there's no arrow that goes directly from mass to atoms. So that means I have to go mass to moles and moles to atoms. So that's just a little trick that I use, and hopefully that will help you on your quiz tomorrow. Good luck and have a good afternoon.